All right, our next video is going to be on the math that goes with the optics. So we're actually going to go back to the second page here. And over here, we figure out how to find where the image was using a ray diagram. Over here, we're going to talk about the math. But I'm going to add one thing to these concave lenses up here. For this, we're going to say the focus is negative. So for these concave diverging lenses, the focus is going to be negative when we do the math. There's only two equations, and they're pretty straightforward. It's 1 over dO plus 1 over di is 1 over f. And dO is distance to the object from the lens. Di is distance to the image. F is the focal length. And we're primarily going to use that to find the distance to the image. We're going to know dO, we're going to know F, we're going to be finding the distance to the image. And then there's another equation. It's M equals SI over SO is minus DI over DO, where M stands for magnification. All right, SO is size of the object, and SI is size of the image. And we'll talk about what that negative sign means in a minute. But basically it's saying if the image is twice as big as the object, so SI over SO is 2, that's the magnification. It's making it twice as big. So we're going to go back to each example, and we're going to do the math. And what we should find with the math is that the values we get for this image should match what we find when we do the ray diagrams. So we're going to start with 1 over dO plus 1 over di is 1 over f. Distance of the object is from the center of the lens to the object is 1, 2, 3, 4, 5, 6. It actually says that here too. It's 6 centimeters away. So 1 over 6 equals 1 over, plus 1 over di, which we don't know, is going to be 1 over the focal length, and the focal length for this is from the center, 1, 2. And again, that was given up here in the problem. So 1 over di is going to be 1/2 minus 1/6. I'm just subtracting 1/6 from both sides. My common denominator would be 6. So 3/6 minus 1/6 is 2/6. And then I got to take the reciprocal. So di is going to be 6 over 2. Di equals 3. And if you look here, if I measure from the center of the lens, 1, 2, 3. 3 would be right on this line, so it's pretty close. And this is actually more accurate than our diagram because I might not have drawn the lines in the exact right spot. Now, for the size, SI over SO is minus DI over DO. So SI, size of the image is what we're looking for. The size of the object was 3 equals minus DI we found was 3, and DO was 6. And if I do this, I'll end up with SI is minus 1.5. Okay, and the minus negative means it's inverted, which it is, and the height of it should be 1.5, and if I start here, it's 1.5 high. So our math verifies what we found from the ray diagram. And we're going to do this just for each of the examples. So for this one, we have SO over here, size of the object. This is the distance to the object because the object is 3 away. And the same lens, so F equals 2. And we're just going to plug in. So 1 over dO plus 1 over di is 1 over f. 1 over 3 plus 1 over di, which is what we're looking for, is 1 over 2. Subtract a third from both sides. I get this. And again, that's going to be a common denominator is 6. So 3/6 minus 2/6 is 1/6. So di, I take the reciprocal, is just going to be 6. And if you look, we count from the center. 1, 2, 3, 4, 5, 6 would be here. So it's pretty close. And then I'll do this over here. Si over So is minus di over do. Plug that in here. So Si over 3 is minus di was 6 and do was 3. And I get Si is minus 6. And if you look at it, 1, 2, 3, 4, 5, it's not quite as long as it should be, okay, but about 6. And negative meaning it's inverted again. All right. And then the third example. So now, we'll do it again. 1 over do plus 1 over di is 1 over f. 1 over 1.5 plus 1 over di is 1 over 2. 1 over di is 1/2 minus 1 over 1.5. I can use 6 for a common denominator again, and this is going to be 3/6 minus 4/6, which gives me negative 1/6. So then di is minus 6. Well, minus means going back the other way, so minus 6, 1, 2, 3, 4. This diagram is a little bit off, okay, but it is back this way, okay? And then Si over So is minus di do. So Si over 3 is minus negative 6 over 1.5. And Si, if I do my math right, ends up being let's see, that's going to be 18 divided by 1.5. Yeah, it's 12. And this time it's positive, okay, meaning it's pointing up, and 12 is 1, 2, 3, 4, 5. It's pretty tall. So again, it matches. And then our last example is going to be with the concave lens. And with the concave lens, we have to remember f is negative. So for this one, f is going to be minus 2. 1 over do plus 1 over di is 1 over f. 1 over do is 1, 2, 3, 4, 5, 6. Plus 1 over di is 1 over minus 2 this time. So 1 over di is going to equal minus 1/2 minus 1/6. So minus 3/6 minus 1/6 is minus 4/6. So di is going to be minus 6 over 4. Di is minus 1.5. Again, minus means it's on this side, and this turns out to be almost exactly the right spot. There's minus 1, minus 1.5. Now, Si over So equals minus di over do. All right, so Si over, this is still 3 for the size of the object, is minus 1.5 over, and do was 6. And I'm going to end up with Si, it's going to be positive 0.75 if I do the math. And if you look, this here is less than 1 high. It looks like it's a little more than a half, so 0.75 also matches very well. So that is the math for lenses.